Dr.R.Eswaramoorthi, Professor, Department of PCE, KSR College of Engineering, Tiruchengodu. Today I am going to take the session in the topic of oscillator. So, why we go for oscillator? An oscillator circuit is capable of producing AC voltage of desired frequency and wave shape without any input signal. So, to test performance of electronic circuit, it is called a signal generator. It can produce square wave, pulse, triangular or sawtooth wave shape. High frequency oscillator are used in broadcasting. Microwave oven uses an oscillator. For induction heating, dielectric heating purpose, we are using the oscillator. So, what are the types of oscillators? Actually, we are going to classify the oscillator as sinusoidal and non-sinusoidal based on the waveform generation. An oscillator generating square wave or a pulse train is called a multivibrator, that is a non-sinusoidal waveform, non-sinusoidal oscillator. Suppose an oscillator generating a sine waveform, that is called as the sinusoidal oscillator. Bistable multivibrator, that is a flip-flop circuit. Monostable multivibrator, astable multivibrator, these are all generate the square wave or pulse. Depending upon the type of feedback, we have tuned oscillator, RC oscillator and crystal oscillators. Generally, we have two types of feedback. One is a positive feedback and another one is a negative feedback. So, in oscillator, we are using the positive feedback, but amplifier uses a negative feedback. So, the gain with positive feedback is given as, that is AF is equal to A divided by 1 minus A beta, where AF is the gain with feedback, A is the gain without feedback, and beta is the fraction of output is fed back to the input. This condition, that is by making 1 minus A beta is equal to 0 or A beta is equal to 1, we can get a gain as a infinity. This condition A beta is equal to 1 is known as also Berkezian criteria of oscillations. So that to get a desired oscillation, the condition should be satisfied. A beta is equal to 1. It means you can get the output without any input. See, this is the one amplifier and A, the gain A, and output is V0. Here we have to apply some fraction of output to the input circuit, that is called as the beta, fraction of output, that is a beta to the input. So, if X and Y are connected, the output will be fed back to the input. VI is the input. So, A into beta VI is the fraction of output given to the input. So, this is the oscillator without any input. It will generate the output, that is some fraction of output V0 is fed back to the input through a feedback network called as a beta. What happens in this circuit? There are three possibilities. First one is If the A beta is less than 1, that is the fraction of output to the input and gain without feedback, A beta is less than 1, we can get the output as a decaying damped oscillations. That is, output will be slowly decreasing with increasing time. So at the initial time V0 is maximum. If the time is going on, it will be decaying. So it is not a proper oscillation. So second one is if A beta is greater than 1, we get growing oscillations. So initially the output will be low. At increasing time, the output will grow up to maximum. So it is also not a sustained oscillations. If third condition, if A beta is equal to 1, we can get the sustained oscillations. In this case, the circuit supplies its own input signal. This is called as the sustained oscillations. How the waveform will comes from the starting voltage? Generally each resistor is a noise generator. So you have one circuit, in that circuit you have a resistor. So each resistor is a noise generator. The feedback network is a resonant circuit giving maximum feedback voltage at frequency f0, providing a phase shift of 0 degree only at this frequency. The initial loop gain is A beta is greater than the oscillations built up only at this frequency. After the desired output is reached, A beta is reduced to unity. So you can get the desired oscillations. For a LC oscillator, we are using the tank circuit, LC tank circuit. Once it is excited, it oscillates at a frequency f0 is equal to 1 divided by 2 pi root of LC. So based on the L and C values, it will generate the frequency. So this is the tank circuit with inductance and capacitance. With the giving a voltage E, it will be excited. This is the way in which how oscillations are produced. The energy keeps oscillating between electric potential energy and magnetic field energy. So this is a damped oscillations. There is no sustained oscillation.